Imagine building something so well that it outlives everyone who made it. In 1977, a team of engineers launched a machine into space with a 5-year warranty. They're retired now. Some have passed away. Their children have grown old. But their creation? It's still out there, 14.5 billion miles from home, moving through a place no human eyes have ever seen. It's crossed into interstellar space. It carries a message meant for civilizations that might not exist for another billion years. And in 2022, after 45 years of flawless communication, it suddenly started sending signals that made absolutely no sense. NASA had a problem, and the problem was 4 decades away, traveling at 38,000 miles per hour into the darkness between stars. September 5th, 1977, Cape Canaveral, Florida. The sky tears open with light as a Titan Centaur rocket pierces the atmosphere, carrying aboard it a spacecraft no bigger than a small car. Voyager 1, destination everywhere. This wasn't just another satellite launch. This was humanity's first real attempt to touch the cosmos beyond our solar neighborhood. While the world watched disco dominate dance floors and Star Wars pack movie theaters, NASA was orchestrating something that would outlive empires. The mission profile seemed almost too ambitious. Fly past Jupiter, then Saturn, using their gravity like cosmic slingshots to gain speed. Study their moons, their rings, their mysteries. Then keep going. Just keep going. Forever, if possible. No one really knew what would happen. Would the spacecraft survive Jupiter's radiation belts? Would its systems freeze in the outer reaches? Would it simply drift into silence, another piece of forgotten metal in the vacuum? The engineers gave it a 5-year lifespan. They built it tough, redundant systems stacked on redundant systems, but 5 years seemed optimistic. Voyager 1 had other plans. March 1979. Jupiter looms ahead. As Voyager 1 approaches, its cameras begin transmitting images that make scientists literally gasp. The Great Red Spot. That massive storm larger than Earth itself appears in stunning detail. But that's just the beginning. The moons. Oh, the moons. Io, Jupiter's innermost large moon, explodes before their eyes. Not metaphorically, literally. Active volcanoes, erupting in real time, spewing plumes of sulfur, hundreds of miles into space. No one expected this. Moons weren't supposed to be alive with geological fury. That was reserved for planets. Then Europa appears, wrapped in a shell of cracked ice that looks disturbingly like frozen ocean surfaces on Earth. Beneath that ice, possibly an ocean with more water than all of Earth's seas combined. And the rings. Jupiter has rings, faint, ghostly, invisible from Earth. But there they are, captured by Voyager's patient cameras. November 1980, Saturn's turn. The ringed giant fills Voyager's view, and the spacecraft threads a path through the most complex ring system humans have ever witnessed up close. Thousands of individual ringlets, braided, kinked, showing gaps and waves caused by tiny moons acting as cosmic shepherds. Titan, Saturn's largest moon, passes below. Voyager's instruments peer through its thick orange atmosphere, revealing a world of methane lakes and organic chemistry. A frozen laboratory of the building blocks of life. Every image transmitted back, taking hours to cross the vast distance at the speed of light, rewrites textbooks. These aren't just pretty pictures, they're revelations. And then Voyager 1 does something no human creation has ever done before. It leaves, not just Saturn, not just the planets, it begins the long, lonely exodus from everything we've ever known. There's no dramatic moment, no boundary marker, just mathematics and trajectory, the spacecraft climbing up and away from the plane of the solar system on a course that will never bring it back. the cameras take one last look backward. February 14th, 1990. From 4 billion miles away, Voyager turns its lens toward home. Earth appears as a pale blue dot, barely a pixel, suspended in a sunbeam. Astronomer Carl Sagan would later call it a mote of dust suspended in a sunbeam, the most humbling photograph ever taken. Then, the cameras shut down forever. Power conservation. Every watt matters now. But Voyager keeps transmitting temperature readings, cosmic ray detections, magnetic field measurements, data from a realm no instrument has ever sampled. Years pass, then decades. The mission that was supposed to last 5 years crosses 10, then 20, then 30. Engineers who built it retire. Some pass away. But Voyager 1 just keeps going, keeps talking. A faint whisper from the edge of everything. August 2012. Something changes. The instruments detect it first. A sudden shift in the cosmic ray environment. The particles streaming past Voyager suddenly aren't coming from the sun anymore. They're coming from outside. From interstellar space, from between the stars. Voyager 1 has crossed the heliopause. Think of it as a wall of fire, though not fire as we know it. It's the boundary where the solar wind, that constant stream of charged particles flowing from our sun, finally exhausts itself and crashes against the pressure of the galaxy itself. Here, the sun's influence ends. Here, interstellar space begins. No human-made object has ever been here before. Voyager 1 is now officially outside our solar system's protective bubble, swimming in the actual medium between stars. The data it sends back is precious beyond measure. What's the radiation environment like? What particles exist in this space? How does the galaxy itself behave in these empty regions? But here's the thing about being the first. You're gathering data no one has ever seen before. You're answering questions we didn't even know to ask. And sometimes you encounter things that don't make sense. Which brings us to 2022, May 2022. NASA's Deep Space Network receives Voyager 1's daily transmission. Something is wrong. The spacecraft appears to be functioning perfectly. Its instruments are taking measurements. Its power systems are stable. Its transmitter is broadcasting at the expected strength. But the data streaming from one critical system, the AACS, the Attitude Articulation and Control System, is gibberish, random numbers, impossible values, data that doesn't match the spacecraft's known state. The AACS is essentially Voyager's compass. It keeps the spacecraft oriented correctly, pointing its antenna toward Earth, pointing its instruments toward whatever they're measuring. If this system fails, Voyager could tumble, could lose contact forever, could die alone in the darkness. But here's the paradox. The antenna is pointing at Earth. It has to be. They're receiving these signals perfectly. The AACS must be working. So why is it reporting nonsense? Teams at NASA's Jet Propulsion Laboratory convene emergency sessions. These are people who've been working with Voyager for decades, who know every circuit, every line of code, every quirk of its ancient computers. Computers running on less processing power than a modern hearing aid, by the way. They send commands into the void, traveling for 21 hours at light speed to reach their distant probe. Then, they wait another 21 hours for the response. Every troubleshooting session takes almost 2 days. Theories multiply. Is it radiation damage? Voyager's been soaking up cosmic rays for 45 years. Is it a software glitch? Some ancient bug finally manifesting? Is it something else? Something unexpected about the environment it's moving through? The spacecraft is 14.5 billion miles away. You can't exactly send a repair crew. But perhaps the most haunting aspect of Voyager 1 isn't what it's sending back to us, it's what it's carrying forward. Mounted on each Voyager spacecraft is a golden record, literally made of gold-plated copper. Etched on its surface are instructions, diagrams showing how to play it, and the location of our sun, relative to pulsars that act as cosmic lighthouses. If you could play this record, you'd hear Earth. Greetings in 55 languages, a baby crying, waves crashing on a beach, wind, rain, thunder, a human heartbeat, music, Bach, Beethoven, Chuck Berry, traditional songs from cultures across our entire planet. There are images, too, encoded in the grooves, pictures of humans, of our cities, of DNA structures, of our place in the solar system. Mathematical definitions. A mother nursing her child. It's a message to whoever might find this spacecraft 1 billion years from now, when our sun might be dying, when Earth might be unrecognizable, when our species might be long gone or transformed into something we can't imagine. It says, we were here. We looked up. We wondered. We reached out. Voyager 1 is carrying that message now into interstellar space at 38,000 miles per hour. In 40,000 years, it will drift within 1.6 light years of a star called Gliese, 440 feet. It won't stop. It will never stop. The mystery of the strange signals. NASA eventually traced it to a corrupted memory location in the AACS computer. They uploaded a patch, software written in 2023, to fix a computer designed in the 1970s, now residing in interstellar space. It worked. Voyager 1 continues its mission. Right now, as you watch this, it's getting farther away. Every second, it's 10 miles more distant than it was before. Every day, nearly 1 million miles more. The signal it sends takes over 21 hours to reach us, growing fainter with each passing year. One day, probably within the next decade, the last of its plutonium power source will decay below usable levels. The instruments will shut down one by one. The transmitter will fall silent. But Voyager 1 will keep moving through the Milky Way, past stars that won't exist for millions of years, carrying its golden record, its message, its testament to a species that looked at the stars and decided to say, hello. Our first true messenger to the cosmos. Our farthest voice in the darkness, still traveling, still out there, still calling home.